Alrighty, guys. When I say read, read this out loud. Ready? Read. Explain the difference between arc measure and arc length. Warning, these two are not interchangeable. Now, unveil the fruit. Please do not do anything with the fruit until I tell you to, and I'll answer the most important question. Can you eat it?
Yes.
When you finish slicing, dicing, mashing, cutting this fruit, when I say dispose of the fruit, if you so choose to eat it, then you may do so. But until then, don't do anything else. Ready? Not yet. Not yet. It'll be there in a second. Okay, ready? Let's just get oriented. This fruit represents the two circles. Okay, so we have circle R and circle E. My center's a little off, but you guys will figure it out. So ready? So step one on your paper, I'd like you to put right there, this is going to be circle R, that's the orange slice, and circle E is going to represent your lemon slice. Okay with that? Okay, now on your paper, I'd like you to draw a right angle, central angle. I'd like you to label this central angle ORA, and label this central angle LE and M. Yeah, it's about 10 second delay on it there. Okay, now, this is your first act of surgery. Someone in your team, as carefully as possible, I'd like you to slice an exact 90-degree wedge and make it as exact as you can. As exact of a 90-degree wedge as you can get. Got it? So you should have two 90-degree wedges going on.
It feels weird cutting. It feels raw. It's going against everything I've ever read.
Ready? Now, the rest of us, let's draw what we just did. Okay, so we have two wedges here. Our orange wedge and our lemon wedge. So this is now representing this. Okay? All right. What these wedges, I want everyone to point to one of the wedges. Point to it like I'm physically doing.
I'm doing it.
Okay? Repeat after me. Say, this is sector area. Say it again. This is sector area. So when we talk about sector area, it is the area of a slice of the circle. So label this sector area. This is sector area. We're going to do some real simple concept. Now, I did not necessarily mean last night that made a whole lot of sense. That's why we're doing this now. Okay, now sector area. Watch very carefully. Every person is going to have to demonstrate this with the fruit. So, watch. A sector area is, so there's my sector area, watch. It is a fraction of the area. Catch that? You push it together, say area, watch. A sector area is a fraction of the area. See that? Grand. Everyone take one of the pieces of fruits and actually say that out loud. Go. Sector area is. Everybody demo. Grab the fruit.
Grab the fruit, Julian. Grab the fruit. I'm not. That's what my hands are over my face.
Alrighty, guys. On the top right, you want to write this down. The wedge is called, we're on the top right, page 2. Page 2. That wedge is called a sector area. Okay, once again, let me demonstrate. So this wedge right here, both the lemon and the orange, that's called a sector area. And a sector area, by definition, is simply a fraction of the circle's area. Guys, please don't chit-chat right now unless I ask you to do something. Stay right with me. Now, a fraction, let me just get this, break this down. A fraction is just a part of a whole. Part, whole. Say part, whole. Good. So we say the fraction, draw a little arrow. The fraction is the part of something over the whole of something. Yeah, I know, that looks like enough. Let's change that. It's okay. P-A-R-T. Got it? Area is just the area. Part over whole. Part, whole. Part, whole. Part, whole. Sorry, whole. Whole. Got it. Now, how do we define our part? Our part, we use this central angle theta. So just write central theta. See that navy blue dot? Put your pencil there. Now swing all the way around. That represents your hole. How many degrees is that? Bam. So that's your hole. Your hole is going to be 360 times area, which is apple.
Really, really good.
Lovely. See, friends? Okay. Behold, box this. This is the equation for sector area. The first time you see it, it looks a little scary because it has a lot of moving parts. But all it is, if you just break it down, is it is a fraction of the area. Do you see that? Fraction of the area. Let's do one together. Actually, we're going to do two. I'm going to do one with you, and I cut you loose to work on your own. Okay. In the circle to the right, we have a radius of 8. Trace the radius. It's 8 centimeters. We want to find the area of the shaded region. So I'd like you to stripe this. That's the area we're going to find. First, we write our equation. Central angle theta over 360 pi r squared. Cool? Get your hands off that calculator. I'm going to show you how to do this without a calculator because you're smart like this. Oh, you so are. Okay, ready? Out loud, what's my theta? 60 degrees. Okay? And that's pi. And my radius is 8, so it's 8 squared. Now watch the magic here. I'm going to break it down like so. 60. 8 times 8 over 360, and I put pi right there. Can you copy it just like that? Just put that pi to the side. Oh. Good. Okay. No, that's all times. Okay, do you see that 0 there? See that 0 there? Goodbye, 0.
Dang. Whoa. Skills.
Okay, ready? Circle the 6, circle the 36.
5 by 6.
6 goes into 36.
5 by 36.
That's 6, that's a 1. Okay, so I just start boxing stuff. I'm going to box an 8 and a 6 now. 2 goes into both. 2 goes into 8 how many times? 4. And then 2 goes down here. 3. And you look, can that 3 go into anything else? Okay, so look what we have left. We have 4 times 8, which is 32 over 3 pi. Check units. Centimeters. It's area, so it is squared, and you are done.
Whoa.
Truly.
What is a fraction? You don't want
Oh, I know. Life is hard. Fractions. I mean, you could do this if you want.
No,
We could do, watch, 32 divided by 3, and I get 10.66 repeated pi centimeters squared. That works too. It's fine. Okay, ready? Everybody pop down to the very last problem. Very, very last problem. Very, very last problem. This one. No, this problem, guys. See lay problem? This problem. Okay. Step number 1. This instructions completely, wholly, totally on your own. You're lonesome. By yourself. Got it? 2, second challenge. Do it without a calculator. I dare you to try. You have 4 minutes. Now, go. Yes. Okay. The 210 is this way, ma'am. That didn't help. The 210 is that right there.
So which side we have to find?
How about you read the instructions?
Oh.
That's okay. You're not the first person. No, not yet. We still have stuff to do. If that bothers you, Jalen, you can pop it over there. You have 4 minutes to do this on your own. When you are done, backtrack to the very first problem in the review section. No, I really want you to try to do it without a calculator. Obviously, I want you to leave it in pie form. What we just did, leave it in pie form. Try not to smooth up the neighbors. Over it, 1.5 minutes. You're done early. You're working on problem number 1 in the review section. Really trying hard not to use the calculator right now. Super hard. If you're done, you're working on problem 1. Got it? Backtrack to problem 1. 30 seconds. I'm going to go over this. Repeat it when we're done. Keep them multiplying in. Not multiplying. Factoring. Should be multiplying. Yes. Okay, guys ready? Yeah? Okay. Zero method. All right. Ready? Let's check. Check. We're going to do this together. Let's check. You should have, watch very carefully. The very first thing, how many of you found 150 degrees? Raise your hand. Kudos, you read the instructions. This is good. Okay. Yes, 2 of you put 210. Why? Because you did not read the instructions. Sector area is 150 times pi times 18 squared over 360. So what's 150 times 18 times 18? 360, leave pi there. Goodbye zeros. Okay, go this, that's 2. Okay, this, that's 9. 15 times 9. A whopping 135 pi units squared. Thumbs up if you got that. Woohoo! Okay, the rest of you, figure out where did you drop the ball. Okay, ready? Flip back to page 3, please. Flip back to page 3. Flip back to page 3, please. Flip back to page 3, please. All right. Your slices. You have 2 wedges right there. Now, what I'd like you to do, on the top of page 3, I'd like you to draw your wedges, please. Just redraw your wedges all by themselves. You have a bigger wedge. You have a smaller wedge. They're still both 90. I'm on the top of page 3. We're just redrawing our wedges. This is 90. What's the degree curvature out here?
90.
Uh-huh. Because measure of a central angle to its arc. Exactly, same. All right, now for another surgery. Now, this is easier if you pick it up. Now, watch carefully. Using the knife, I want you to slice the pulp away from the peel. See, like this? So that you're going to end up with like a peeled eyebrow. Just like so. Okay? It's a little bit easier with your knives if you actually pick it up and slice it using the serrated edge. So you have 2 eyebrows. It's easier if you pick it up and use a serrated edge. You want 2 eyebrows. It's easier if you pick it up and use your edge like this.
Is it okay if the interior part of it got destroyed?
It's okay. All I want are 2 eyebrows. Okay, ready? The rest of us. I want you to now draw your 2 eyebrows. Your 2 eyebrows look something like this. This is now arc OA and arc LM. This is being represented by the orange peel and by the lemon peel. You okay? So those are both still 90 degrees. Stay right with me, guys, because I'm about to blow out your minds. Truly. Okay. We know that the measure of the arc OA is 90 degrees, correct? And the measure of the arc LM is also 90 degrees. Because measure of a central angle to its arc. Excellent. Ready? Watch very carefully. These are both how many degrees curvature? You follow? Everybody say 90 degrees. 90 degrees. Say measure the same. Measure the same. Now, last step. I want you to take this and I want you to notch it. Do you see what I'm doing? Notching. Do not cut all the way through. You're going to notch. That's notch. Then turn it upside down and flatten it so that the peel is up, and I want a flat piece of peel. You're flattening it. That's why you notch it. So we take the curve, and to get that curve, you're going to have to notch. See, notch, notch. That's what I mean by notch. Okay, now flatten it and put them right next to each other. Flatten them right down so that they're two flat pieces. You're going to have to kind of smash them a little bit. They're right next to each other. Got it? Flatten them. Try not to cut it. Pay attention, guys. Here is the pivotal point in the movie, the climax of the story, the summit of your mountain. This point right here. Look very carefully. I like you to draw the relative lengths of your peels. Try to draw it relative to what yours is. You have a longer peel. That's OA. Now try to use your peels as a model. My peels, a little over half. Come in at the end of lunch. If you have leftovers, you're welcome to them.
Oh, that's
Here is the most important question. Write the word length. Length. Okay, listen to my question very carefully, because at the bottom of this page, you're going to have to answer this particular question. The degree measures are the same. The degree measures are the same. Let me demo it physically. Everybody say, measure same. This was 90-90, correct? Okay, watch. Length's different. Measure same. Length's different. Come up over here. Ready? Right. Big bet. Same. Different. Same. Different. The main question is, why? Great. No, not because. None of this parental rule stuff. Why do I want it? Because I said so. Not in this class. Ready? Excellent. I actually want you to answer this. It's part of your sign-off. I want 1 to 2 sentences right there. How can the measures be the same, but the lengths be different? Swing into your team. Start talking. Go. You're talking, you're right, guys. Go. You're talking, you're right. Guys, can you go back to my
Don't do it. Don't fall into the same thing that I did. So, you know how it is. You are so lucky. Miserable. Not even Ariel. Has nothing to do with what he was censored by made him.
You're not writing a sentence. You're running, you guys. I want a sentence. How can the measures be the same, but the length be different? That's what I'm asking.
I'm starting. You said you watched. You learned different.
That's the same, that's different. What? They're both nice.
Exactly what I said. I have done exactly what
So the circumferences are completely different, right? But the so you take up the same amount of paper and measure the circumference.
Rotate. Forward. Miss Hines, lights please. Lights please, Miss Hines.
I got you.
Ready?
She wants King.
All right, guys. You did a fabulous job. I heard the word circumference several times. It's length. So our degree curvature can be the same, but curvature, a circle's always a circle, but the circumference length can be different. So that's the trick, and be very careful on SATs especially. They will use the word length and measure, and you have to realize those are two different things. They're not the same thing. Okay, ready? At the top, gentlemen, we're focused on this right now. On the top of page 4, so an arc length, it's just a fraction, we're almost done here, of circumference. We're on the top of page 4. You only have 4 pages after this. It's really easy. Ready? Arc length, therefore, is a part over a whole times circumference. I'm just going to use a giant C there. I'm on the top of page 4. Our part starts the same way. It's central theta. Central angle theta over the whole degrees, which is 360. C!
I see.
D5. All right. Behold, that is how you find arc length. Okay, let's do one together. And then we are done. Okay, so it says we have right here a radius of 8. We want to find the arc length of P to R. So stretch that and write the word length. Our ultimate goal is to find the length. Put a question mark there. Measure of a central angle to its arc. Good. So the measure of PR is 60 degrees. Guys, gentlemen in the corner, you're not chatting unless you're talking about this particular problem math class, which I know at this second you're not. All right. Now, arc length is going to be theta over 360 times d pi. Bring this back. Shush you. So, this is theta, which is 60. Physically trace your diameter. Out loud, what's your diameter?
12.
Okay, 16. 5. It's okay.
I saw 6 and I was like, oh, hey, look at that.
Now, we're going to hack away here. Go by zeros. 6, that's 6. 2 goes in the boat. 2 goes in here how many times? morning, guys. And, okay, so we can do 8 pi over 3, and it's just centimeters, not squared, because it is length. Or another form of pi form, you can get it in what's called decimal pi form. 8 divided by 3, which could be 2.66 repeating pi centimeters. Want to get it in decimal form? All my answers are in decimal form too. Is it area or length, sir? Length is how many dimensions? It's okay. It's good. Yes, you're correct. All right, guys, you're ready to be alone. Start working on page 5. You're like, Miss Way, do not let go of my hand. Roll up to the front. So you guys, push back a little. Oh, guys, here's the magic words. Dispose of everything, which means you can get rid of everything. If you want to eat the fruit now, be my guest. Otherwise, I do have deals back here. If you want a deal, you can come get a deal. Friends, you are not ready to be alone, and you want to do the first page with me. Come on up. Okay. Ready. Amber, can you read number 1 out loud there? Got it. Okay, what is it? What's the last? Excellent. Now, do you see we have a regular polygon on interior? Write the word each, because that's what the song's going to sound like. Each angle of a regular polygon. Sum over side. So let's write this down. 1 interior angle equals sum over sides. Do you see what I just did there, Amber? That's why we have to memorize stuff. Okay, now let's see what we actually have here. See that 140? Guess what the 140 is? It's the what? So it's going to pop over here. Do you see what I just did there, Amber? Okay, now the question is, Christian, this is for you. How do you find the sum of interior angles? Yes, sides minus 2 times 180. I was just seeing what you're going to do with that. I'm just like being cruel right now. Over sides, which is n. Do you see that? Got it? We're going to pop this over 1, cross multiply. Your job is to solve for n. And then once you know the number of sides, you tell me what is it called. Got it? You're going to do your math yourself. I'll be back in 1 minute. I got to go stir something in my pot.
No, shut up, shut up. Shut up. Wow, I'm so. Why?
Do the math here. You should be getting 9 here, guys. Okay, because it's 140n equals 180n minus 360. It ends up being negative 40n equals negative 360. Divide. We okay? N equal, it doesn't matter. N equals 9, and that's called a what? Nonagon. Okay, we're going to finish this full first page together. Okay, so number 2, we're going to express all our answers with or without pi. I like to do pi form because it's easy peasy. Yes, sir. Yes, sir. Red, whatever you can get, it's right from there. Ready? I'd like you to trace the angle PAQ. 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 Anna, what's that degrees, dear? Fabuloso. 150 degrees. Great. Kyle, can you tell us what's the degree curvature of PQ? 150 degrees as well. Because measure of the notice that word, underline that word measure. I need you to start noticing that word measure. That's the buzzword here. Exactly. Fabulous. Angle 2, which I thought. Good. All righty. Ms. Hines, what's our radius? Good. Mr. Twist, what's our diameter? Fabulous. Okay. Now, let's do our math here. I want you to shade the sector area PAQ. Shade it. Shade it. That's what we're finding first off. Ready? Okay, let's write our equation for sector area, which is theta over 360 times pi r squared. Amber, that means fraction of area. Fraction of area. Okay, ready? Amber, what's our theta here? Yeah, what is it? It's the same, right above it, dear. That's 150 times pi times our radius, which is 18 squared. And you're so brilliant. We're going to do this without a calculator. So brilliant. You're so brilliant. You're going to do this without a calculator. Watch. 150, 18 over 360, and just tack on 5. Okay, so goodbye zeros. How about we circle 18 and 36? That's even. That's even. What can we do with that? 18 goes into 36. Oh, hey, buddy. That's 2. Circle. Okay, I'll be there to help you in just a moment. Ready? 2 goes in here 9 times. And then we're going to do 9 times 15 by hand, because you're smart like that. I know you guys are so dependent on calculators. Try it again. 135 pi units squared. Ta-da! Okay, you do the one on the right, that's arc length, and then go check. You do the arc length on your own.